Hello everyone. Welcome to this section where we part ways with theory and jump into the practical aspects of an MCP server and client. We have two files, a server that holds tools and a client that calls them. This section covers two transports, stdio and streamable HTTP, and you can toggle between them by commenting and uncommenting a single line in both the server and client. And let me quickly show you those two. In the server, it is the mcp.run line, which could be toggled on and off between line 62 and 64. And in the client, it's the same that could be toggled off between line 29 and line 31, depending on which type of transport you prefer. We're going to proceed with stdio to begin with. With stdio, the client spawns the server as a subprocess, and they communicate through standard input and output. No network, no ports, no separate server process to manage. With streamable HTTP, the server runs independently as a web server, and the client connects to it over HTTP. The same tool calls work identically either way. We walk through the server first, and then the client setup. Then each tool called together. Imports. FastMCP turns Python functions into MCP tools, handling the protocol, schemas, and serialization. Feed adds description and defaults, making tools self-documenting. One line creates the server. The string is the server's name. What clients see when they connect, every tool registered below belongs to this instance. Tool 1, double underscore servings, a simple return value. The function takes a number of servings and returns double that number. Simple multiplication. At mcp.tool is the only thing that makes this an MCP tool. The docstring becomes the tool's description in the schema. List underscore dishes, tool 2, is returning a list. The function returns a hard-coded list of available dishes. No input required. Tool 3, suggest underscore wine, looks up a dish in a pairing dictionary and returns a wine recommendation, falling back to Chardonnay, a safe all-rounder. Title gives the tool a human-readable display name, separate from its function name. Suggest underscore wine is the call identifier. Wine pairing suggester is what you'd show in the UI. We'll see exactly how this surfaces when we call list underscore tools. Next, scale underscore recipe, documenting parameters with field. Field adds a description to each parameter and an optional default. Parameters with default are optional. Only dish is required. We'll see this in the schema when we call list underscore tools. Next, starting the server with the two transports. Comment and uncomment to switch transports. The tool calls work identically either way. With stdio, just run the client, it spawns the server. With streamable HTTP, start the server first, then run the client. Next, we jump onto the client. Imports. Async IO runs the async client. OS and sys handle path construction and OS detection for finding the right Python. Both transport clients are imported. stdio underscore client for subprocess mode. Streamable underscore HTTP underscore client for HTTP mode. Only one is active at a time, depending on which line is uncommented in run. Everything else, client session, types, get display name, is the same, regardless of transport. Next, finding the right Python interpreter. This builds the absolute path of the virtual environment's Python. Wrong interpreter means the server can't find MCP and fails. Handles Windows versus Unix paths automatically. Next, configuring the server launch. A simple data object describing how to start the server, which executable to run, which file to pass as an argument. This is only needed for stdio transport. stdio underscore client uses it to spawn the subprocess when using HTTP. stdio server parameters is not involved. The server is already running and the client connects by URL. Next, the connection and each tool call. Here, we are opening the connection. We can toggle transport here. These two lines are the only thing that changes between transports. comment out one, uncomment the other. Everything below. Client session, initialize, all tool calls stay identical. stdio underscore client spawns the server as a subprocess using server underscore params and returns read-write streams connected to it. Streamable HTTP underscore client opens an HTTP connection to the already running server and returns read, write, and a third argument, which is the session metadata that we discard currently. Client session wraps whichever streams come in and speaks the MCP protocol over them. Session.initialize performs the handshake the same way in both cases. Next, list underscore tools. Here, we first get the raw schema. The raw response is written to tools underscore response.json. Let's first run the client and see this in action. This line on line 40 would have produced the raw tool JSON dump. Let's inspect that together. 4 tools listed here. 1 per function decorated with @mcp.tool. Double underscore serving is one of the tool. Let's move this to the right. The description comes from the doc string. Whatever you write there is what the client sees. Servings has no description, just integer because no field was used. Output schema is generated automatically from the return type. You never write it. Next, let's look at list dishes. This is the description coming through the doc string. The return type is annotated as an array. Our next tool, suggest underscore wine. This tool has a title. The other tool did not have a title, and that title comes from this parameter with the decorator. When we have a title, get underscore display name would use the title name instead of the function name. Next, scale underscore recipe. All parameters have a description here because field was used. This is what an AI reads to know what to pass. Serving and unit are not required because they have defaults. Only dish is a part of the required list. Then let's print a clean summary line by line of tool coming from line 43. This lines up name, title, and the result display name side by side. For 3 of the 4 tools, display matches name. Suggest underscore wine is the only one where they differ because it's the only tool with a title set. Next, invocation. I'm going to expand this. Every call tool response has 2 ways to read the return value. Result.content and result.structuredContent. Content is always text. FastMCP serializes whatever the tool returns into text content items. Structured content preserves the typed value as a Python dictionary, so you don't have to parse strings. The client reads both. You'll see the difference in each invocation below. Our first invocation, double underscore serving. The first call. Here, we first print the raw result from this invocation. The full MCP response object, everything the protocol returns. Look at content, the text wire format, and structured content, the typed value, and is error. This is the part of the framework. Next, we're reading content by looping through text content to get the text value. Content.text is always a string. The integer 8 came back as a string 8. Next, we are reading structured content. The typed shortcut, no parsing needed. Structured content is an integer, same value already typed. Second invocation, list underscore dishes. First, we print the raw result. Again, notice content. This content is different. This has 3 separate text content, 1 per string. This list was split across 3 text items on the wire. Structured content keeps it whole. Next, we are looping through each item and collecting into a list. 3 iterations to reconstruct what was one list. This is why structured content exists. Then we are reading structured content the full list directly. No iterations needed. Same data already assembled. Just grab it with the result key and you're done. Next, invocation 3. Note, suggest underscore wine is not by its title. Titles are display metadata only. Here, we first print the raw result, single text content, single return string. Then, we loop through the content and then print the result. Again, we also have a string return via structured content, same pattern as the others. Next, invocation 4, scale underscore recipe. Here, only dish is passed. Servings and unit are omitted, and the server fills them from the defaults. First, printing the raw result. Confirm the defaults kicked in without the client specifying them. Next, we are looping through content to capture the result. Finally, we are using structured content to grab the typed output. Field defaults applied. Server side, the client sent one argument and got a full resolved response. Next, async io.run creates the event loop needed to run the async run function. Then, if name equals main, guard ensures main only fires when the file is executed directly, not when it's imported. Here, the server has registered 4 tools, each teaching one concept: a plain return value, a list return, a title tool, and field documented parameters. The client launches the server over HTTP, handshakes, and calls each tool. Every result has a content list of text content items for reading as a text, a structured content field preserving the typed value. The async with block handles process and session cleanup automatically. This is the foundation everything else builds on. Now, to switch it to streamable HTTP is quite easy. All that we have to do is comment out this line and uncomment the other. Next, we'll do the same in the client where we comment out this line and uncomment this. Now, let's run the server. This is running as expected. Let's open another terminal and let's run the client. And that's your output with the streamable HTTP transport. Thank you. We covered a lot today. Now, go run the code, rewatch it, break it, and rebuild it. That's how you actually learn. Make it your own.